All right, click and close for just a very briefly here. And I'm going to make this as quick as possible, but this will help a little bit. So I got some examples here related to the very last assignment, the 1.7 assignment. But I think it'll help even with your understanding of the other stuff. So I'll let you just kind of tilt those closed. All right, so let's take a quick look at some very simple inequalities. Very simple. So how about if we solve this? What kind of symbol is that? That's an and. Good. Okay. Flipped or is an and. It's an and statement. Let's take this in two parts. First part here, 4x minus 2 is greater than or equal to 30. What are the two steps necessary to solve that for x?
Add 2.
Add 2, good, and that's going to give me 4x is greater than or equal to 32.
Divide by 4.
Divide by 4, which leaves me with x is greater than or equal to 8. How about the other side? We'll do the same thing. So over here, 2x plus 2 is greater than or equal to 2. First I subtract 2, which gives me 2x is greater than or equal to 0.
Divide by 2.
Divide by 2, which gives me x is greater than or equal to
0.
0. Good. So there's my answer. Okay, and it's an and statement, right? So we want to think about, now, the last assignment, the 1.7 assignment, is a very quick assignment. What it's devoted to, and I think I've already talked a little bit about this, it's devoted to problems that have weird answers. The solutions are weird. They're not normal. So how do we interpret these? But it gives us a little insight into how all this stuff works if we think about it. It's a good thing to think about. So let's graph this. Let's graph this solution. We've got numbers at 0 and 8. And what do we get here? We have the solutions x is greater than or equal to 8. Everybody agree that looks like that? Mm-hmm. And we have the solution x is greater than or equal to 0, which looks like that. Okay, so what's my solution going to be? Everything, okay, so we got a couple of options probably. One option that would maybe make sense is all values of x greater than or equal to 0. What would the other one be? I'm going to show you something here. Let's make sure we understand exactly what we're talking about when we say and or. Okay, an and statement, an and inequality is an intersection. Okay, it's an intersection. It's where both inequalities have to be true at the same time. The solution is where both are true or it doesn't work, right? So in terms of a graph, that's going to be where the graphs overlap. Okay, only where they overlap. So where do these graphs overlap? In other words, what parts would be both red and blue?
8 and above.
8 and above, right? So when this is an and statement, you see that connection. For an and, they both have to be true at the same time. So only the places where they're both true are part of the and compound inequality solution, right? And think about the numbers. They make sense. Like, for example, if we pick a number in between here like 4, you tell me, does this sound right? 4 is greater than or equal to 8, and 4 is greater than or equal to 0. True or false?
False.
False, because it's not greater than or equal to 8, right? And implies everything has to be true, right? Let's pick 10. 10 is greater than or equal to 8, and 10 is greater than or equal to 0. That's true, isn't it? Both of those statements are true, so it makes sense that 10 would be in the purple region as part of our solution, okay? So we end up with the solution x is greater than or equal to 8 in this case, right? Okay, so what about if we do this? Just grab those. I can't quite. I can grab all that stuff. Let's do this. If I do the same, almost the same problem, everything's the same, except now it's an or symbol instead. But everything else is the same. So over here, I'm just going to subtract 2 and get 4x is greater than or equal to 32, divide by 4, and get x is greater than or equal to 8. And same work over here, right? We end up with x is greater than or equal to 0. But this time it's an or statement. Okay, so if it's an or statement, now think about our solutions. 0 and 8, two graphs of the solutions of each of these inequalities. The red graph, like before, x is greater than or equal to 8. The blue graph, x is greater than or equal to 0. But now, what's the solution to the statement x is greater than or equal to 8 or x is greater than or equal to 0? Or inequalities are unions, and so only one has to be true for the compound inequality to have a solution there, right? They don't both have to be true, only one does. So this isn't the intersection of the graphs, this is the sum of the graphs. In other words, any place that is blue or red would be a solution of this inequality, right? So where's that going to be?
From 0 on.
Yeah, that makes sense. So all values greater than or equal to 0. And let's check some values just to demonstrate that. Let's pick 4. True or false? 4 is greater than or equal to 8, or 4 is greater than or equal to 0. True. Only one of them has to be true, right? How about negative 10? Negative 10 is greater than or equal to 8, or negative 10 is greater than or equal to 0.
False.
False. None of those are true, right? But anything above 0, at least one of those is true, right? So my solution here is x is greater than or equal to 0. Okay? See the difference? Okay, so let's go back and look at a normal one and just kind of think of it in this new way, in this expanded way. I mean, this isn't anything radically different than what we talked about, but it's just a little bit more expansion of what we talked about earlier, and that's the way math works. You get something and then you kind of expand your understanding a little bit. In science, when we talk about theories in science, I mean, like the theory of gravity is one of the biggest, most extensive theories in physics, right? So does a theory mean that if I drop this, it may or may not fall to the desk? Is it a hypothesis that it's, no, it's not. When we talk about the theory of gravity in physics, what are we talking about? Well, we're talking about our understanding of everything about gravity. And it just keeps growing and growing and growing. Like it's not, if you study physics, you'll find that when I drop this pen, and maybe we'll have time to talk about this later in the year, but what's really happening there is this pen is falling into a higher dimensional gravity well. And we know that to be true, but we didn't know that when we first started studying gravity. That's stuff that we've added since Einstein developed the theory of general relativity, right? So a theory, and math is the same way. Your understanding of math is the same way. It's you develop an understanding, but you gradually build on that and it gets more complete, right? So let's look at an example like one we've talked about previously here. Another really easy one to solve. Let's take this an and compound inequality. Let's take the left one. What do I do first?
Add 6.
Add 6. 3x is less than or equal to 6. Divide by
3.
So x is less than or equal to 2. And how about this guy?
Add 5. I mean, subtract 5.
Subtract 5. So 2x is greater than or equal to negative 10. Divide by 2, x is greater than or equal to negative 5. So let's graph this. Now this is an and inequality, right? So we've got numbers at negative 5 on the left and 2 on the right. So x has to be greater than or equal to 2, or less than or equal to 2, sorry. So I'm going to go close dot, right, to the left, and x is greater than or equal to negative 5. It's an and inequality, so it's an intersection, right? So what's my solution going to be then? Okay, so I'm hearing it. So we're going to go between what two values?
2 and -5.
There you go, right? So we'll include the endpoints because they're solid. But those are the only places where both are true at the same time. And that's consistent with what we've done all unit, isn't it? Right? But now maybe you get a little different look at that. We're thinking about it specifically as an intersection. Yes, Russ?
So I have a question. How do we answer the first problem that you put up on the board? The and.
That one right there?
Yeah.
That's the answer right there.
Okay.
Yeah, that's the solution. Now put a box around it. Okay? If you put in x is greater than or equal to 8 and x is greater than or equal to 0, that's technically true, but it's not simplified, right? I don't need to say all that stuff. I can just say x is greater than or equal to 8. The second one, all we would say is x is greater than or equal to 0. Okay? Now what about this one? Well, the way we write this one it's easier, I know these are separate statements, but look at the interval that it describes. The best way to say this one would be what? X is
Greater than or equal to -5.
good, and
Greater than or less than or equal to.
boom, there it is, right? So there's our three-part and inequality, because it matches up with the overlap, with the intersection of the graphs. And that you feel your knowledge is kind of gradually growing there? Does it all make more sense now? Okay, how about one more and I'm turning you loose. So last one, this is an OR, right? So same kind of thing. Let's take first inequality. First I subtract 1. So I get 4x is less than or equal to 8. Divide by 4, x is less than or equal to 2, or this guy over here.
Subtract 5.
Subtract 5, so I get 4x is greater than or equal to, what, -32? Divide by 4, x is greater than or equal to -8. Okay, so let's graph this one then. Now this is an OR statement. So I've got numbers at -8 and +2. X is less than or equal to 2. Well, that looks like, that looks like this. Less than or equal to 2, sorry. X is greater than or equal to -8. And I want you to think about this. This is an OR statement. Is this an intersection or a union?
Union.
Union, right? So it's a combination of everything. It's the sum of the two. It's a union. So what's my solution here? Say it again.
X is greater than or equal to -8, or X is...
Okay, now, so you're stopping yourself. Every place where either one is true, right? So, somebody find me a value of x that's not a solution of either the red or the blue? Is there one? No, so what's the solution? No. All reals. It's all reals this time, isn't it? Because look, everything, I can take -1 billion. Let's take that number. -1 billion is less than or equal to 2, or -1 billion is greater than or equal to -8. True or false? True, because it's less than or equal to 2. It's an OR statement. Positive Google. You know what Google is? Google is, yes, 10 to the 100 power. So positive a Google is less than or equal to 2, or it's greater than or equal to -8. True, it's greater than or equal to -8, right? So this is all reals. There you go, okay? And so I guess if I graphed it on here, it would be everything, right? Okay, you can work.
Okay.